In today's video, we're going to be taking a look at One-Way ANOVA in Python through two different examples. Our first example is going to be a little bit more of a manual calculation just to show you how all these steps work. We will be using NumPy though to make our lives easier. The second example is going to utilize SciPy, and we'll be able to get the results of our ANOVA test within just a few lines of code. I'm also going to be covering concepts like Levene's test and Shapiro-Wilk test in this video. So if you aren't familiar with them, make sure to brush up on them. There's some of the other videos on this channel. And if you're already familiar, awesome. Let's start going over a little bit more information about ANOVA, and then we're going to jump into some. All right, so some information on ANOVA. So it's considered or called analysis of variance, but I'm going to go by ANOVA because it's so much easier to say that. It allows you to compare the means of three or more groups. But what you're going to be doing though is only looking at one independent variable. So you can think of this as different examples, right? So on the medical side of things, you might think of like different treatments on medicine. On sports, you might have different things like different training methods or using a different coach. A pretty good example on here is the effect of different pre-workouts on a max bench press. So you want to see the different pre-workouts A, B, and C, and you want to see the means of the max bench presses. And look, the only factor that we're going to be looking at specifically is going to be that pre-workout. Maybe the different groups have the same exact max bench press. Maybe let's say, for example, it's 135, and then you go and give them the three different pre-workouts, and then you see what the results are after that. If you want to compare means of different groups based off of two different independent variables, that's going to be considered the two-way ANOVA. We'll cover that in another video. The null and alternative hypothesis, null hypothesis, all group means are equal. Alternative hypothesis, at least one group mean is going to be different. Pretty self-explanatory. Our assumptions is first, each group should be approximately normally distributed. You can test this through the Shapiro-Wilk test. One thing about ANOVA though is if you do have a larger sample size, it's okay if it's not normally distributed, and that's due to the central limit theorem. The other side of things is you want to make sure the variances across the different groups should be approximately equal, and we can do this test through Levene's test. Again, I have a video on Levene and Shapiro if you want to check those out. If the variances are going to be different, you're going to want to use Welch's ANOVA. We'll probably make a video on that as well. All right, there's 10 steps, right? Hypothesis, alpha value, Shapiro-Wilk for normality, Levene's for equal variances, then calculate group means and overall mean, SSB, SSW, degrees of freedom, MSB and MSW, F-statistic and p-value, and then draw a conclusion. We'll go through these really fast. So first, let's say we want to compare three teams' batting averages. So the null hypothesis, all teams' batting averages are equal. Alternative hypothesis, at least one team's mean batting average is different. So you have team A, B, and C. Here's all their batting averages. And we could even say, like, on the independent variable side of things, it could be we're taking a look at different coaches, or we could have another one where we could be taking a look at different types of training methods, right? Think of the independent variable for this scenario. I didn't really mention it, but regardless, let's take a look at the Shapiro-Wilk test for normality, right? All of them are above 0.05 alpha, so we're good on the normally distributed. And Levene also 0.842, also once again above 0.05, so we are good to go. Then we're going to calculate each team's mean and then the overall mean, and that is on the slide right now. And then we want to calculate the SSB. I have the formula right over here to the top right. So NA, NB, and BC size, right? Each of them are going to be 9. XA is the mean of group A. X is just going to be the mean of all the groups. You plug in the numbers, you get 0.012. Then we calculate SSW with this within group sums of squares. There's a lot of math behind it. So at the very end, we get SSW A, B, and C. And then we add them up together for SSW in general. We get the value down below. Degrees of freedom between groups is going to be the 3 groups minus 1 is 2. Within is going to be the number of samples, which 9 times 3 is 27, minus 3, 24. And then we can calculate MSB and MSW. So we have those two values over here. And then we calculate our F-statistic and p-value. We have those over there. And the median batting average across the three teams is not the same since P is significantly less than the alpha value. So we reject that null hypothesis. I know I went through this a little bit faster, but there's a lot of steps, and we'll still be coding this out in Python and then showing you some shortcuts with SciPy, which makes things always really easy. So make sure you get your notebook ready and let's start coding. All right, so let's get started. What we're going to do first is we're going to import in NumPy and then stats. So import NumPy as NP, and then import SciPy stats, and that should be the only things that we need for this video. Also, I'm going to set a default alpha for this video, and I'm going to say our alpha value is 0.05. And once that's there, we can go through our first example. So let's take a look at our manual example. We'll say example 1, and this is manual, right? And what I'm going to do first is we're going to have baseball batting averages for 3 teams. So I'm just going to paste in the batting averages. So first one, team A, 285, 270, 290, 300, 275, 295, 280, 265, and 285. And also, if I remember correctly, these should line up with the PowerPoint slides I went through. I am recording these 2 different days, so I apologize if this is a slightly different example, but when I was prepping the video, I'm pretty sure it is. But 260, 250, 245, 255, 270, 265, 250, 240, and 255 for Team B. And then Team C over here, we have 305, 295, 310, 320, 300, 315, 290, 305, and 315. Okay, so what we're going to do first is we're going to take a look at the Shapiro-Wilk test for normality. So we'll say Shapiro-Wilk test normality, because one of the assumptions is we're going to have a normality across all 3 of these. So we're only caring about the p-value in this instance, so that's why we can put an underscore like this. We don't need that value, and I'll just say p-value Shapiro A, and you can still grab the other value if you want it, but it doesn't really matter to me. So we're going to do stats.Shapiro, and then we're going to pass in A over here, and I'm going to do that for all 3 teams, right? And I'm just going to print out these results. So print out, we just want to confirm, right? We don't want to have any p-values under 0.05. So that's the first one over there. Now let's take a look at B. So we'll put B over here, team B. Did I capitalize B? Yeah, I did. And print that out. So 9.6, we're good, right? This one for B is also 9.6, so we're good there. And then lastly, we're going to look at C. So let's just grab that. Pro value C. Put team C over here. And we'll also print C. And what do we get? 0.85. So all Shapiro's, yeah, those worked well. So now what we need to do is take a look at Levene's for equal variance. So we'll mention this over here. Levene equal variance. And again, I don't care about this first value over here. So what I can do is say that, and I'll change this instead of Shapiro C. I'll just say Levene test, right? And this is going to be equal to stats.Levene, and then pass in our teams, right? So we have team A, then we have team B, and we want to have team C. Right. And let's print out this value. Print, again, it should be way greater than 0.05 based off of the data I prepped. And look, 0.84. So we are good to go. So let's start going through the manual calculation. So I'll go over here and say step 3 is calculator means. Calc means. And let's go through each of them, right? So all we have to do is say mean A equals, And we'll just do np.mean. Thank you, NumPy, for making this easy. And we'll go team A, right? And we can print that out and see how this looks. You can see 0.2827. Now let's just do this for other means, right? So we'll go mean B, and then we'll do mean C. So B, team B, and then C and C. And I'll just print those out as well. And also we need to have all these teams together. So we'll just grab that overall mean. So we'll say overall mean equals np.mean, and then pass in each of these teams. So I'll just copy team A, say team A plus team A plus team A. I'll switch these to B and C. And what I'll do now, same with the print, I'm just going to copy these. I'll change this up in a second. So all I'm doing is just changing print of mean A to mean B. So you guys can see the value for B. B is 0.254. For mean C, right, we already ran that cell, but we'll say for the mean on that side of things is 0.306. And lastly, we'll have this overall mean. I didn't run that cell above, I thought I did. And 0.2638. So we are looking pretty good right now. Well, actually, it's off because I didn't put team C there. So rerun that really quick. Just saw that. And we should get 281. Okay, so we're looking good now. And what we want to calculate now, and I think this was step 4, is the SSB. So that is going to be your between group sum of squares. So here's how we can do that. So what we'll say is SSB equals, we'll have length of team A, we'll times that by mean of A minus overall mean, and we're going to square that. So square, and we're going to do that for each of these teams. So I'm just going to copy this code, and also we're summing these up together. So whoops, we're summing all these together. So I'll say plus and plus, and I'll put that there. And let's just change these out, right? So this is B, that is B, and then all I have to do is change this up to C over here. All the lengths are the same, but regardless, we have C, we have B, we have A for SSB, and I just want to print this out to confirm the same numbers over here. So print this out. 0.012, awesome. Now let's calculate SSW. So step 5, SSW within group sum of squares. And we'll go each of these groups one at a time. So SSWA equals, and we'll have sum over here. And what we'll do is we'll say x minus mean of A, and we're going to square this. And for x in team of A, right? So again, from like the slides, right? X is this individual value in team of A. So we'll take like 285, right? We'll subtract that from the mean of A. We'll square it, and we're going to go through all these and then sum them up in team A. So we're going to do that this for A, B, and C. So B and C. I'll print out those values too for you guys. But let's go over here and change those up. So we have A, B, C, and then A, B, C again. And you know, just doing this makes you appreciate SciPy because it is a lot of work, right? So print, and I'd much rather just use SciPy than going through this step by step every single time. Although you don't really have to. You can make a function, but regardless. All right, A 0.001, B, make sure everything's there. Yep, B 0.007, and then C 0.00078. And then to get our final SSW value, we're going to add these up together. So we'll have A plus B plus C, right? And I'll just change up each of these. So we'll go through here. A, change it to B, and then we got C. And then we just print this out. Print out our SSW. Check that out. 0.002. And awesome. Now let's calculate our degrees of freedom. So step 6, degrees of freedom. And what we're going to do first, let's do the easy one, right? df between equals 3 minus 1, right? We have 3 groups, subtract 1. So that's going to be 2. I don't think I have to print that out. And then we're going to do df within. That's going to equal the length of team A plus team B plus team C. And then we're going to subtract 3. So minus 3. And then let's print that out. And if I remember correctly from the slides, we had 24 over here because there's 9 for each team. And 24. Awesome. So now what we can do, and this is step 7. Step 7 is we're going to calculate our MSB and MSW. So MSB and MSW. And MSB equals SSB divided by df between. Why is that? There we go. Must have had a typo. Print out this MSB. 0.006. And then let's calculate our MSW. So MSW equals our SSW divided by df within. So grab our df within. And then print out our MSW. And you see we get a very small value over there. Now we can calculate our F-statistic. So step 8, F-statistic. And this is our manual calculation of that. F-statistic manual. That's just MSB divided by MSW. Right. You can print that out. And we need this F-statistic to calculate our p-value. You can see we get 56.337. And lastly, let's find our p-value. So step 9. This is our p-value. Right. So p-value over here. We'll say p-value manual equals stats.f.sf. Then pass in this F-statistic manual. And then we're going to put both of our df's over here. So we have df within and df between. So df between. And then grab df within, which will be right here. And that'll give us our p-value. Great. And print out our p-value. And it's essentially 0, right? So we can draw our conclusion, right? Go back over here that these 3 means are not the same, right? Way off. And we reject the null hypothesis. Sometimes I'll do an if else, but we've already gone through this example, I believe, from the slides. So no need to repeat it all. Let's go through a way easier one with SciPy. So this is going to be example 2. And what we're going to look at for example 2 is marathon times with different shoes, right? And let's go through them. So what we're going to have first is Nike Pegasus, which are my daily trainers. And we'll have the different marathon times over here. Then we're going to have Vaporflies, which is my first shoe I wore for a marathon. Actually, not my... it was my second marathon I wore Vaporflies. And we have that over here. And then we have a shoe I want to try, which are Speed Goats by Hoka. I've never worn a Hoka shoe, but a lot of people recommend them, especially for trail running. And we have those over here. And let's take a look at our different data points. So first thing that we're going to do is like above is we're just going to get our Shapiro values. And then what we'll do after our Shapiro is we'll get Levene. And then what we can do is use our shortcuts. So it's going to be a little bit more manual again with Shapiro. We got to go through each of these, right? So Shapiro, p-value, Pegasus equals stats.Shapiro, pass in Pegasus, right? And then I'll just print out all these p-values at the end this time. So we'll just grab all of these over here. We'll have Vaporfly next. And yeah, I could just write an if-else statement too, but another video. All right, so just run these over here. And we'll just print these out. So print out our Pegasus p-value. .96. Great. Now let's print out our Vaporfly value. 0.96, and then print out our SpeedGoat value. 0.96. So we're good there. Okay. And then we know it's normally distributed. And what we want to do now is find our Levene, right? And Levene will tell us our variance. So all you have to do over here is our p-value Levene equals stats.Levene. And then grab all three of these again. Pegasus, Vaporfly, SpeedGoats. So Pegasus, Vaporfly, and SpeedGoats. And print out our p-value Levene. And you see it's 0.9, and you can see it's 0.945. So we assume that these have equal variance. All right, and now we can do our one-way ANOVA test. So one-way ANOVA test, and check out how easy this is, right? So if we want to grab our F-statistic, we can just say F-statistic here, right? And I ignore them for a lot of the videos because I focus on p-value, but we'll go over here for p-value ANOVA over here equals stats F one-way, then pass in Pegasus, Vaporfly, and then SpeedGoats. Right. And it's awesome as we print out our p-value. You'll see essentially 0, right? 3.471 to the -6. And we can print out this nice little if-else statement, which I already had prepared. So reject the null hypothesis, different means, right? If it's less, and then, which it is, so it'll print out that one. Else, right, fail to reject null hypothesis, same mean, well, they have different means. And reject the null hypothesis, different means. And yeah, that's generally it, right? So essentially what we're doing, right? First you go over here, you run your Shapiro, get your p-values, make sure it's normally distributed. Then we go over here, Levene, make sure the same variance. And then we can stats.f one-way, Pegasus, Vaporfly, SpeedGoats, and we get our p-values super easy like that. Or you can go the manual process that I showed you above. There's a lot of extra steps there, right? So I'd recommend using what's available in SciPy. Hope you guys enjoyed this video on the one-way ANOVA test. If you did, make sure to subscribe to the channel. We're trying our best to reach 100,000 subscribers in 2025. We're going to be uploading at least 3 videos every single week. Now, if you want to learn even more about statistics within Python, I have a few videos linked down below in the description and a playlist right over here for you guys to check out.